Every pilot knows the shape, the forward-swept tail, the tiny cockpit, the speed that makes a Cessna look like it is standing still. This is the story of Mooney, the fighter design that perfectionism ruined. Al Mooney was a genius who wanted to build the most efficient machine in history. He created a steel tube masterpiece that could cross the country on a sip of fuel. But that same obsession with perfection created a machine so difficult to build and so expensive to fix that it nearly took the entire company down with it. Behind the records and the trophies is a tragic history of bankruptcies and broken promises. There is a dark side to the Mooney way that owners only discover when they see their first maintenance bill. How did the world's most efficient airplane become a financial trap for its biggest fans? And was the pursuit of the perfect flight actually a recipe for total failure? Al Mooney's creed was simple, almost ruthless: waste nothing and let nothing slow you down. The M20's silhouette, with a knife-edged nose, a forward-swept tail, and that impossibly narrow cockpit, announced a machine built for speed, not comfort. In a world of rounded Cessnas and gentle Pipers, the Mooney cut through the sky with the precision of a scalpel. Its laminar flow wing, drawn from NACAO's most advanced airfoil research, reduced skin friction by 12% over its nearest rival. Flush rivets, seamless fairings, and a propeller hub buried in its cowl all served a single master: aerodynamic cleanliness. Pilots who first flew the M20 in the mid-1950s spoke of a transformation. The numbers told the story: a cruise speed above 170 knots, burning less than 7 gallons per hour at 75% power. On a measured run, one M20 covered 732 nautical miles on just 28 gallons of fuel, an efficiency that left the rest of general aviation trailing in its wake. The phrase began to circulate among flight instructors and test pilots: it is the F1 car in a tractor world. Al Mooney's design notebooks, still preserved by his family, reveal a mind obsessed with the equations of lift to drag, with every ounce of structure scrutinized for necessity. His directive to engineers was uncompromising: if a part could be made lighter without risk, it was done. The M20's steel tube cabin cage, welded with surgical precision and then wrapped in thin aluminum skin, delivered a cockpit that was both rigid and featherlight. The result was a payload to gross weight ratio unheard of in 4-seat aircraft, a figure that became gospel in every Mooney sales brochure. Test pilots like Bob Ferguson recalled Mooney's wind tunnel sessions, where he would halt the test to sketch a better seal for a control surface, chasing the smallest possible gap. The trailing edges of the M20's control surfaces were sealed so tightly that even the slipstream seemed to hesitate before passing by. Louise Herring, a senior engineer, remembered the internal mantra: every pound we save is another mile of range. The industry took notice. Aviation Week profiled the M20 as the most efficient airplane in America, its fuel burn 30% lower than a Cessna 172. The aircraft's forward-swept tail became a marker for pilots who wanted to go farther, faster, on less. In the eyes of its admirers, the Mooney was not simply a machine, it was an ideal made real, a testament to the belief that engineering could conquer the limits of physics and commerce alike. Yet beneath the records and the acclaim, a question lingered: how far could one push the pursuit of purity before it became a liability? For now, the M20 stood alone, an F1 car, brilliant and unyielding, racing down a runway built for tractors. In the late 1950s, as the Mooney M20's reputation began to ripple through the hangars and flight clubs of America, a quiet tension threaded its way beneath the surface of admiration. The M20's beauty was not only in its speed, but in its refusal to compromise. A machine so lean, so purpose-built, that every inch seemed to whisper of calculation. Yet, in the back rooms of maintenance shops and on the factory floor, there were already signs that this pursuit of aerodynamic purity carried a hidden weight. The general aviation market was entering an era of mass production and standardization. Cessna and Piper churned out hundreds of aircraft each month, their designs shaped as much by the needs of mechanics as by the dreams of pilots. Mooney, by contrast, operated more like a boutique atelier than a factory. The M20's assembly line moved slowly, each fuselage cradled in custom jigs, each weld scrutinized for perfection. The tolerances demanded by the laminar flow wing and the steel tube cabin cage were measured in thousandths of an inch. These were not the broad strokes of industrial manufacturing, but the fine brushwork of an artist who refused to let go of the brush. Within Mooney's own correspondence, requests for tighter mandrels and more precise forming dies became routine. Factory supervisors logged delays as they waited for specialized parts that could not be borrowed from the stockroom of a neighboring brand. The M20's construction was a closed system, each component a bespoke answer to a single question. How do you make the airframe lighter, the drag lower, the performance higher? Even the engine cowl, with its recessed propeller hub, required hand finishing to preserve the aircraft's clean lines. What looked like elegance from the ramp was, up close, a dance of complexity and precision. The metaphor began to circulate among those who built and maintained the airplane. The M20 was the F1 car in a tractor world. It was a machine that could win races, but only if the pit crew could keep up. For every knot gained in cruise speed, there was a corresponding demand on craftsmanship, on time, on money. The very features that set the Mooney apart, its flush rivets, its seamless fairings, its tightly sealed control surfaces, also set it apart from the economies of scale that kept its rivals afloat. Industry analysts, reading the early production figures, noted a pattern. Unit costs at Mooney were rising even as demand increased. The tooling for the laminar flow wing, for example, had to be recalibrated after every batch, a process that slowed output and drove up expenses. The tricycle landing gear, first envisioned as a drag-reducing marvel, was eventually reshaped to fit existing jigs, a quiet concession to the realities of manufacturing. Letters between Al Mooney and his production managers reveal a growing tension, an unspoken question about how far economics could be pushed before the economics began to bend. For now, the acclaim drowned out the doubts. The M20 was a marvel, a testament to the arrogance and brilliance of engineering. But already, in the shadows of its success, the cost of perfection was beginning to show. The seeds of a future reckoning had been sown, waiting for the moment when admiration would give way to inquiry, and when the price of purity would demand its due. Lou Herring, one of the quiet architects behind the Mooney M20, once described the design process as a war against the ordinary. The M20's laminar flow wing was not simply an aesthetic decision, it was a battle plan. By adopting the NACA 65-210 airfoil, the design suppressed turbulent airflow across nearly 60% of the chord, squeezing every possible mile out of a gallon of fuel. This was not a theoretical gain. Flight data from the late 1950s confirmed that the Mooney's skin friction was 12% lower than any contemporary four-seater. Flush rivets, meticulously faired seams, and a cowl that swallowed the propeller hub, all of it served the relentless drive for aerodynamic cleanliness. Yet, the brilliance of the M20 was never limited to its surface. Hidden beneath the aluminum skin, the steel tube cabin cage defined the airplane's soul. Herring's engineering notebooks, still archived in Kerrville, show the load paths traced in blue pencil. The cage formed a rigid box, distributing wing and landing gear loads through chromoly tubes rather than relying on the skin alone. This internal skeleton allowed the aircraft to absorb up to 5 times its own weight in a crash, a fact later borne out by accident records. In the NTSB 2000 report on a forced landing at Vance Brand Airport, investigators found the cabin had retained its shape, the cage holding firm even as the rest of the airframe twisted and buckled. Survivability in the Mooney became a matter of geometry and steel. The cage was both a technical marvel and a harbinger of trouble. Each tube, welded to a tolerance of plus or minus 10,000ths of an inch, had to align perfectly with the forward bulkhead and the main spar. The assembly jigs, custom built for the purpose, became as much a part of the aircraft's identity as its forward-swept tail. The aluminum skin, stretched over the cage, was there not to bear loads, but to keep the air smooth and the drag low. The result was a structure that weighed just 30 pounds more than a comparable monocoque, but could withstand impacts that would have crumpled an all-aluminum fuselage. That precision came with a cost. The Mooney's steel tube cage was a triumph of engineering arrogance, a refusal to accept the compromises of easier manufacturing or cheaper repairs. In the cold arithmetic of crash survivability, the M20 stood alone. But the same perfectionism that made the airplane a legend on the ramp would, in time, become its mortal design flaw. For every knot of speed and every mile of range, there was a hidden cost in complexity, in labor, and in the slow, creeping corrosion that would haunt the fleet for decades to come. The F1 car in a tractor world had found its survival cell, but at a price that would echo through every invoice and every bankruptcy petition that followed. Perfectionism had a price. The invoice arrives with the weight of a verdict. 35 hours of labor, each one accounted for in tenth of an hour increments, line by line. The shop rate, $145 per hour, multiplies the hours into a sum that startles even seasoned owners. Parts, $3,200, all for specialized chromoly tubes, gussets, and corrosion-inhibiting compounds that exist nowhere but in the Mooney catalog. The total, after shop supplies and environmental fees, crests just above $9,800. For many, this is the first true reckoning with the price of purity. A mechanic, one of the few still certified for both aluminum and steel tube airframes, lays out the challenge. The Mooney's forward fuselage is a lattice of welded steel, sealed inside a skin so tight that a single misplaced rivet can ripple the airflow and cost a knot of cruise speed. To reach a corroded crossmember or a cracked weld, the entire interior must be removed. Seats, panels, floorboards, even the main fuel tank. Each tube must be cut, matched, and re-welded according to FAA specifications, then inspected by dye, penetrant, and X-ray, a process that routinely doubles the labor estimate of a comparable Cessna or Piper repair. The jigs are so precise, plus or minus 10,000ths of an inch, that even a seasoned shop can spend hours aligning a single replacement tube. The fastener count alone dwarfs that of its rivals, each one torqued to a value dictated by Mooney's original design notes. Owners tell of the moment when admiration turns to anxiety. The annual inspection, already more expensive than most, can uncover a patch of rust or a hairline crack that triggers a cascade, a required Form 337, a call to the factory for parts, and a wait while the only available mechanic clears space in his schedule. The invoice, when it comes, is not just a bill, it is a reminder that the Formula One car in a tractor world demands a pit crew of specialists, and that every knot of speed extracted from the air must be paid for in hours, dollars, and patience. The financial burden is not theoretical. For some, the repair cost approaches the resale value of the airplane. For others, it means months grounded, waiting for a part or a slot in a crowded maintenance hangar. The arithmetic of perfection is unforgiving. The tighter the tolerances, the higher the cost of correction. In the end, the owner is left with a machine that remains a marvel to fly, but whose very brilliance has become a mortal design flaw, a masterpiece that extracts its price in silence, through invoices that read like quiet obituaries for a dream that could not survive the realities of the shop floor. In February 1969, Mooney Aircraft Corporation filed for Chapter 7 bankruptcy in Colorado. The petition named dozens of creditors, parts suppliers, machine shops, even the Kerrville Utility Company, each debt a sign of a company bleeding out. The cycle repeated in May 2020, this time in Delaware, with debts over $185 million and a last-ditch plan to sell off acclaimed tooling. The filings pointed to the same culprits: material shortages, warranty reserves drained by repairs, and a backlog of airworthiness directives that never seemed to shrink. Inside the factory, the plant manager's logbooks captured the daily grind. Specialized fasteners for the steel tube cage sat on back order for 45 days, freezing production and leaving already sold aircraft grounded. Dealers, once the backbone of Mooney's sales, received mass termination notices first in March 1969 and again in July 1994, each one a quiet signal that the network could no longer hold. The phrase "aircraft on ground" echoed through dealer correspondence, as in a 2021 complaint, a $4,200 invoice, and a 28-day wait for a single tension bolt. Every day a Mooney sat idle, owners paid the price, and the company's cash reserves slipped away. Since 1965, the M20 series has faced 84 separate airworthiness directives. Each new airworthiness directive, addressing spar corrosion, elevator weights, landing gear seals, meant more labor, more parts, more downtime. By 2020, the average compliance cost for an M20J reached $12,500 per airframe. Inspections often revealed cracks or corrosion, setting off repairs that could rival the plane's value. Many parts were unique to Mooney, requiring custom fabrication and months of waiting. Dealers and mechanics, once loyal, began to step back. Maintenance logs filled with deferred repairs and grounded planes. Warranty claims piled up, draining reserves with no relief in sight. By the time of the final 2020 bankruptcy, the collapse felt less like a sudden disaster and more like the slow unraveling of a company built for a world that no longer existed. The ledger of Mooney's ambition is written in both numbers and memories. For every pilot who marveled at the M20's impossible speed, there is an owner who faced the reckoning of a maintenance invoice that rivaled a year's salary. The aircraft's legacy, so often celebrated in the pages of Aviation Week and on the lips of instructors, is inseparable from the rows of terminated dealer agreements and the bankruptcy dockets that trace a pattern of hope, struggle, and surrender. The verdict, in the end, is not ambiguous. Mooney's fighter design, a machine born of aerodynamic purity and the relentless discipline of its creator, stands as a masterpiece of engineering. The laminar flow wing, the steel tube cage, the sealed trailing edges, these were not the indulgences of a dreamer, but the calculated moves of a mind determined to wring every last knot from the sky. The M20 delivered, again and again, on its promise of speed and efficiency. It was, and remains, the F1 car in a tractor world. But the same choices that set the Mooney apart condemned it to commercial fragility. The bespoke parts, the laborious repairs, the endless parade of airworthiness directives all became the mortal design flaw that no marketing could erase. Dealers, once the apostles of Kerrville's vision, found themselves stranded by parts shortages and warranty claims they could not resolve. In one dealer's letter, $4,200 for a tension bolt and 28 days grounded echo the larger tragedy. The cost of purity was not only measured in dollars, but in lost trust, stranded aircraft, and the slow unraveling of a network that once spanned the continent. The catastrophic outcome is plain. This was a corporate expiration not from lack of brilliance, but from the refusal to compromise. The Mooney story is a biography of genius undone by its own ideals, a lesson written in the margins of every invoice and the silence of every grounded airplane. In the final tally, engineering perfection achieved flight, but perfection alone could not keep the company aloft. Today, the Mooney stands as an F1 car in a tractor world, elegant, uncompromising, and mortally flawed by its own perfection. The catastrophic outcome of corporate expiration haunts every hangar that shelters one. In this industry, engineering arrogance still tempts designers to chase purity over survival. Every Mooney reminds us, brilliance without concession is a mortal design flaw, and the market never forgives a masterpiece that forgets the world it must serve.